What if I told you that one poisoned cache entry, one overlooked API check, and one compromised update could cascade into a full-scale breach affecting thousands of companies at once? That's not science fiction. It's exactly how some of the most damaging cyber attacks of the last decade unfolded. In episode 2 of this masterclass, we saw how a simple SSRF bug led to AWS IAM key theft and a total cloud takeover. If you missed that, go watch it after this video. But today, in episode 3, we're stepping into even darker waters: web cache poisoning, API BOLA, and supply chain compromise, and how chaining them together can turn medium bugs into billion-dollar disasters. Before we start, quick but important disclaimer. Everything in this masterclass is for educational purposes only. These demos are recreated in controlled lab environments with intentionally vulnerable setups and fake credentials. Never attempt these techniques on systems you don't own or don't have written permission to test. Stay ethical, disclose responsibly, and always remember, our goal here is to learn, not to exploit. Here's the roadmap for today's journey. We'll begin by understanding modern cloud attack chains. Then we'll break it into 3 parts. First, web cache poisoning, where attackers turn the edge servers we all rely on against us. Second, API BOLA, the #1 API threat today. Third, supply chain, how one poisoned update can compromise thousands of organizations. Then they'll stitch them together into a full chained attack, walk through real-world case studies, and finish with defenses you can implement to break the chain before it breaks you. Why talk about chaining? Because attackers rarely stop at one bug. Research shows chained vulnerabilities are 5.3 times more impactful and cost an average of $23.6 million per breach. Think about it. Cloud infrastructure is distributed, APIs open new doors, shared services blur security boundaries, and third-party dependencies add supply chain risks. As the Cloud Security Alliance put it in their 2025 report, the most devastating cloud breaches come not from one high-severity bug, but from multiple medium-severity bugs chained together. That's why this series exists, to teach you how to think in chains. Let's start with web cache poisoning. Imagine a giant restaurant where thousands of people eat from the same buffet line. If one attacker slips poison into the food at the start of the line, everyone after them gets sick. That's web cache poisoning. Attackers manipulate unkeyed inputs like HTTP headers to inject malicious responses into the cache. And because caches like CDNs serve millions of users, one poisoned entry can spread to everyone. Here's how it works. The attacker sends a request with a sneaky header like x-forwarded host evil.com. The cache doesn't realize this input should be ignored. It stores the poisoned response. Now every normal user asking for that same resource gets the attacker's poisoned content back. One poisoned cache, multiple victims. It's efficient, scalable, and devastating. And this isn't theoretical. Studies show 78% of cache poisoning attacks use header manipulation. On average, 3.2 million users are impacted per incident. Detection takes 12 hours, which in internet time is an eternity. Attackers have used host header poisoning and cache key tricks to inject XSS payloads, hijack sessions, and even serve fake login pages from trusted CDNs. When the edge is poisoned, the blast radius is massive. Next, we move to APIs, the backbone of every modern app. And here we meet BOLA, broken object level authorization. Think of APIs as doorways. BOLA is when the door checks your ID card format, but never checks if the card actually belongs to you. That's why BOLA has held the #1 spot in the OWASP API security top 10 since 2019, accounting for around 40% of all API attacks. Here's the basic flow. A user makes a request to /API users /123, their own profile. If the API fails to check ownership, an attacker can just change it to /API users /456 and suddenly access another user's data. There are advanced tricks too, like ID wrapping. Instead of a simple number, attackers wrap IDs in arrays or JSON objects to bypass authorization checks. But the root issue is always the same: missing object level checks. Let's break it down further. Simple ID parameter manipulation. Change 123 to 456. Array wrapped IDs, where APIs fail to validate nested inputs. Batch processing exploits, where APIs skip checks inside bulk operations. And here's the shocking stat. 86% of apps tested still had some form of BOLA exposure. That means if you're testing APIs in bug bounty, this is the single most valuable area to focus on. What does it cost when BOLA goes unchecked? $3.8 million is the average breach cost. 291 days is the average time before detection. 318% higher cost if the vulnerability stays hidden. In finance, the numbers are even worse, around $4.2 million per breach, 10% higher than other sectors. If you have ever wondered why API security is in every CISO's top 5 concerns, this is why. The good news? You have tools. Kite Runner for API discovery and BOLA testing, Burp Suite with extensions focused on authorization flaws, OWASP ZAP, free, open source, and getting stronger each year. As a bug bounty hunter, knowing how to script parameter changes and automate BOLA checks is a must-have skill. In episode 2, we saw how SSRF unlocked the cloud metadata vault. In episode 3, BOLA gives us direct access to data that should never be ours. Now we climb one level higher, the supply chain. Here's the terrifying reality. One hacked update can compromise 18,000 organizations. That's exactly what happened in the SolarWinds breach. Attackers inserted a backdoor into a trusted software update, which was then distributed to thousands of companies, including government agencies. The average dwell time before discovery? 18 months. That's a year and a half of attackers roaming free inside networks. Here's the chain. Attackers compromise the build environment, inject malicious code, bypass signing checks, and ship the poison package. Customers, trusting the vendor, install the update. And just like that, attackers have a beachhead in thousands of organizations at once. One source, thousands of victims, it's the ultimate force multiplier. Let's revisit SolarWinds. From late 2019 to early 2021, attackers infiltrated the Orion software updates. Over 18,000 organizations were affected, including 9 federal agencies. The estimated recovery cost? Over $90 million. Again, this isn't theory, it's the modern reality of supply chain compromise. All details here are based on public reports, shared for educational purposes only. So how do these pieces connect? First, an attacker starts with web cache poisoning, injecting malicious responses. Second, they pivot to API BOLA, harvesting unauthorized data. Third, finally, they exploit the supply chain, turning one poisoned update into thousands of victims. When chained, the impact multiplies 5.3 times compared to isolated bugs. This is the cloud kill chain of 2025. Here's the attack chain in one view. First, cache poisoning with headers like x-forwarded host evil.com. Second, API BOLA unauthorized data access. Third, supply chain malicious backdoor update. Research shows 93% success rates for cache poisoning attempts, 87% of APIs still vulnerable to BOLA, and mass compromise from supply chain attacks. This is why we need to think in chains, because attackers already do. How do we defend? Let's start with cache and APIs. For caches, segment user sessions, enforce strict cache key rules, and never store sensitive content in public caches. For APIs, enforce contextual authorization, use unpredictable IDs like UUIDs, and add API gateway rules to validate ownership. Here's the encouraging part. 93% of cache poisoning attacks are preventable, and 87% of BOLA exploits can be stopped with proper controls. Break the chain here, and you stop the cascade before it begins. On the supply chain side, demand SBOMs from vendors, validate package integrity, monitor suppliers continuously, and diversify providers. And overarching everything, adopt zero trust. That means never trust, micro-segment your networks, use just-in-time access, require continuous authentication, and monitor everything. The results speak for themselves. 76% of organizations implementing zero trust report reduced breach impact. Break one link, and the attack chain falls apart. In episode 4, we'll push into even more advanced ground, brute forcing SSO, shadow SaaS, and multi-cloud lateral movement. These are the kinds of chains that keep CISOs up at night. So if you haven't subscribed yet, do it now. And don't forget to hit the bell so you get notified. And if you're new here, I recommend going back and watching episode 1 and 2 after this one. See you in episode 4. Thanks for watching. Stay secure.